The AC method, or factoring by grouping, is a good general method for factoring trinomials, but there are some special cases, and if we catch on to those special cases, we can speed up our process of factoring, which is great. Anytime we can work a little faster, save ourselves some legwork, that's a good thing. In example 20 and 21, we want to look at some special cases. In example 20, we have 4y plus 1 squared, and what we want to do is expand that binomial. Keep in mind that since we have that quantity squared, this means 4y plus 1 times 4y plus 1. And from there, we'll FOIL to expand this to 16y squared plus 8y plus 1. In example 21, we can do the same thing, keeping in mind that squaring this quantity means to take that quantity times itself, and then we'll FOIL again to get 25w squared minus 50w plus 25. What's special about these two cases is that if we look at our first term, this is the same thing as the quantity 4y squared, and our last term is the same thing as 1 squared. Then what we can notice is that 8 is the same thing as 2 times that value for a, 4y, that value that we have in our first term, squared, times the value that we have in our third term, squared. If we take 2 times 4y times 1, we would get 8y, that middle term. Similarly, when we look at example 21, this first term is the same thing as 5w squared. The third term is 5 squared. And this value of 50 that we have in the middle is 2 times 5w times 5. So there's a specific pattern that's happening there where the middle term is equal to 2 times the quantity in the first term that's being squared and the quantity in the third term that's being squared. We refer to these as perfect square trinomials, and when we have something that fits that pattern, we can factor that as either a plus b, that quantity squared, or a minus b, that quantity squared. And what we're looking at for that difference, the change in the sign there, is the sign of that middle term. If the middle term is positive, it's a plus b. If the middle term is negative, then it's a minus b. Again, what this is doing is giving us a shortcut to factoring particular problems. If we look at example 22, 64x squared is the same thing as 8x, that quantity squared. 16 is 4 squared. So then what we need to check is 2 times 8x times 4 to see if it equals that middle term. In this case, 2 times 8 would be 16, times 4 would give us that 64x that we're after. So the form of this polynomial matches that pattern, meaning we can just automatically jump to factoring this as 8x minus 4, that quantity squared. And we know that it's going to be minus because we have minus 64, that middle term is negative. So our sign here will be to subtract 4. In example 23, we want to, again, verify that pattern. What we have is 6a squared and 5 squared. So if 2 times 6a times 5 is equal to 60a, which it is, then we meet the conditions for this pattern, and we're going to be able to factor this without going through that entire AC method or some other process. we'll be able to just quickly jump to factoring this as 6a plus 5 squared. And again, we look at that middle term to determine the sign of that factored expression.